So when we're doing long division, regular long division, the divisor goes on the outside, this goes on the inside, correct? What did we do on the diagonal? On the diagonal, we multiplied, okay? On the vertical, we subtracted. Do we all see that, yes or no? We good on all that? Yes? Okay, great. Because now we're going to do polynomials.
Oh, dear Lord.
Oh, dear Lord. That big. Okay? So this is not a big deal because the denominator goes where? On the outside. What goes on the inside? The top, 6x cubed minus 19x squared plus 16x minus 4. Start writing. Don't just look at me like, what is she waiting on? I'm not waiting on anything. Move it along. Okay? Now, what you need to do every time you see this, you need to check to make certain that you are not missing any, and I say any, of your lovely powers. So if I look at this, 3, 2, 1, 0, am I missing any powers in there? No. When you're not missing any powers, that's a good thing, because then you are lining up your like terms appropriately. If you are missing a power, you need to put something in place of it. 0, if I'm missing an x, put 0x. If I'm missing x squared, put 0x squared. That way you have a placeholder there. So we all understand that. Okay, now, what do I multiply x by to get 6x cubed? 6x squared. Put that over top of the x squared position. So 6x squared times x gives me 6x cubed because we multiply on the diagonal. Now what is 6x squared times negative 2? Minus 12x squared. Do we see that? We multiplied on the diagonal, not just to one term, but to two terms. Now what do I do vertically? You're subtracting a quantity. When we subtract a quantity, we are actually distributing that negative. So this turns into plus, that turns into minus, and this turns into plus. Do we see that? Because you're distributing the negative, right, Matt? Join the crowd. We've been doing it all day. Okay, so if I'm adding straight down now because I changed my signs, the x cubes cancel out, and what's negative 19 plus 12? Negative 7x squared. Bring down the rest of the polynomial. Now, what do I multiply x minus 2 by to get negative 7x squared? What do I multiply x by to get negative 7x squared? Negative 7x, right? So minus 7x squared. So if I multiply by minus 7x, I distribute on the negative, on the diagonal, negative 7x times x is going to be negative 7x squared. Negative 7x times negative 2 is 14x. And what do? I subtract the quantity, right? So what happens to the negative on the outside? It changes to a positive, and then all the other signs change also. So now what's negative 7x squared plus 7x squared? That's gone. What's 16x minus 14x?
2x.
Minus 4. Now, what do I multiply x by to get 2x? By a 2. So what do I do on the diagonal? What do I do on the diagonal? So 2 times x is 2x. 2 times negative 2 is minus 4. What do I do down vertically? I'm subtracting a quantity, which means this changes to plus, that's minus, and this is plus. Those all cancel, and I have a remainder of 0. What does that remainder of 0 mean? That this right here is my answer. Can you see that?
Please say it's all hard.
Do we understand that? Let's do it again. X cubed minus x x cubed minus 5 divided by x minus 1. What goes where? X minus 1 goes on the outside. What goes on the inside? X cubed minus 5. I have a problem. I'm missing a whole bunch of letters, aren't I? So actually, what this is going to be is this is going to go away. And I'm going to put 0x squared plus 0x and then minus the 5 at the end. Why am I doing that? Because I want to put my placeholders in there, right? So I can line up the correct like terms. Do we understand that, yes or no? So what do I multiply x by to get x cubed?
X squared.
I'm going to multiply by x squared. So x squared times x is x cubed. X squared times negative 1 is minus x squared. What do I do? Vertically. Subtract. So if I'm subtracting a quantity, yes, I'm going to change the signs. Do we see that? This is gone, and I'm left with x squared plus 0x minus 5. What do I multiply x by to get x squared? I'm going to multiply it by x. So this is going to be an x here. I put it over the x placeholders, yes? So multiplying on the diagonal, x times x is x squared. X times negative 1 is going to be negative x. What do I do? I subtract. That changes the minus to plus. That changes to minus. This changes to plus. This cancels out. I'm left with x minus 5. What do I multiply x by to get x? 1. So I'm going to multiply this by 1 up here. So 1 times x is x. 1 times negative 1 is negative 1. Distribute the negative, and what happens? This becomes a positive minus. I don't care what you do as long as you don't screw up the problem. This cancels out, you get negative 4 left over. What is that negative 4? It's your remainder, so my answer to this is going to be x squared plus x plus 1 plus negative 4 over x minus 1. Because you put the remainder over your divisor. Remainder over divisor. Remainder over divisor. Not so bad, right? Tonight's homework is 1 through 12 all. I'm going to get you started on it. And then we're going to go over last night's homework. Number 4. Number 4 is x to the 4th plus 5x cubed plus 6x squared minus x minus 2 divided by x plus 2. Now they write it all out horizontally in your textbook. I went straight from writing it horizontally into my box. Do you see that? Okay, are we ready? Okay, first thing I need to do is I need to ask, am I missing any powers? 4, 3, 2, 1, 0. Am I missing any? No, since I'm not missing any, what do I need to do here? I need to ask myself, what goes in, what do I multiply x by to get x to the 4th? X cubed. It's going to give me x cubed there. So x cubed times x is x to the 4th. Plus x cubed times 2 is going to be 2x cubed. What do I do?
Subtract.
Subtracting a quantity. Since I'm subtracting a quantity, the signs change. This becomes positive, that becomes negative. That becomes negative. My x to the fourth cancel out, and this is going to give me 3x cubed plus 6x squared minus x minus 2. Now what?
Well, figure out what you need to.
What do I multiply x by to get me 3x cubed? 3x squared. So 3x squared times x gives me 3x cubed. 3x squared times 2 gives me 6x squared. Now I'm going to subtract. When you subtract, that means everything changes signs. That's gone, and that's gone. What am I left with? Negative x minus 2. Now, what do I multiply x by to get negative x? Minus 1. So that minus 1 comes down here. So negative 1 times the x is going to be negative x. Negative 1 times 2 is negative 2. What am I doing? Subtracting a quantity. So that's going to give me plus, plus, plus. That's gone. That's gone, and I'm left with a 0. What does that mean? That means right up here, this is going to be my answer. Okay? Since there's no remainder, you know what this means? It means it's a factor. You understand that? It means it's a factor. It goes into it evenly. Number 7, let's do this one together.
You don't have to do the order, do you?
Nope. Yep. Okay, number 7. Am I missing any powers? So as I look at this, I have three. Story of my life. Story of my life. 3, 2, 1, 0. So what do I multiply 2x squared by to get 6x cubed? 3x. I come all the way down here beside the x, and I put it above it. So 3x times 2x squared gives me 6x cubed. 3x times 1 gives me 3x. And I put that 3x underneath my x-like term. We all understand where I put that 3x. How many of you did not do that? Watch that you put it underneath its like term, okay? So now we're going to subtract. So if I'm subtracting, this changes into plus, minus, and that one's minus. The 6x cubed are gone. What's 10x squared plus nothing? 10x squared. And what is x minus 3x? That's going to be minus 2x. Drop down the plus 8. What do I multiply 2x squared by to get 10x squared? A 5. So multiply on the diagonal. 5 times 2x squared is going to be 10x squared. 5 times 1 gives me a 5. Again, putting it underneath its like term. And subtracting a quantity. So therefore, this is going to change to addition, subtraction, and that's going to be subtraction. Add straight down. This gives me negative 2x plus 3. Can I do anything with that? No, because the degree of my remainder down here is a 1, whereas this over here is going to be a 2. Do we all see that? Yes or no? We good with that?
So if it,
Which means my final answer is going to be 3x plus 15 plus negative 2x plus 3 over 2x squared plus 1.
yeah.
Sorry, plus 5, thanks. Do we see that? Yes or no? Okay. The top part is my remainder, the bottom part is my divisor. So I take the chunk that's on the top, 3x plus 5, plus the remainder divided by my divisor. Every time. Any questions over tonight? Okay. The worksheet from last night, get it out. Any problems with 1 through 5? 1 and 2 confused you.
Well, I think one of the asking questions, I understand it.
Okay, a minus 1 has to be this real number. These two things have to equal each other. I need to find a, so a minus 1 has to equal 5. Right?
Yeah.
So that means I add 1, a is equal to 6. You get me? Can you do the b now?
Yeah.
Okay.
Thanks.
Any other questions 1 through 5? Do we not understand the b term still?
What is one?
b plus 3 has to equal 8 because they both have the i's, right? So therefore subtract 3 and I get b is equal to 5.
So that's all that problem.
That's all that problem was, is just finding out what a and b represent.
Well, it definitely looks harder than that.
It wasn't
Me
hard.
too.
Number 5, the square root of negative 0.0004. First of all, that's decimal. Turn it into a fraction. So that's negative 4 over what? Tens, hundreds, thousands, 10,000s. Correct? Yes? That's going to be the square root of both of those. So this is going to be the square root of I squared times 4, because 4 is a perfect square. Is 10,000 a perfect square? What number multiplied by itself is 10,000? So 1,000 times 1,000 is 10,000? So 100 times 100 is 10,000? We all agree on that now? Making sure. They knew as soon as I'd say that. Okay, now what is the square root of I squared? I. What's the square root of 4? 2. What's the square root of 10,000? 100. So you actually have 2i over 100, which brings it down to I over 50. Do we see that? Yes or no? Assuming number 8, just because it's fractions, you guys apparently fall at your knees at them. Immediately I'm going to distribute here. So that's negative 3/4 minus 7/5 I minus 5 over 9 plus 1 over 6i. Combine like terms. Well, negative 3/4 minus 5/9 are like terms. And negative 7/5 I plus 1/6 I are like terms. So what's my common denominator between 4 and 9? 36. So 4 times what gives you 36? That's a 9. So 9 times 3 is negative 27. 4 times 9 is 36. So 5 times 4 is 20.
Go down to speed racer.
Guys, these are fractions. You are in pre-calc. No offense. But if you don't understand fractions by now, you better pick up a calculator. We did a really big number, which means you need to reduce it majorly. So this is negative 47 over 36. That is just this part. Now I need to add over here a common denominator between 5 and 6 is 30. So this I is on each one of them. 5 times 6 gives you 30. So 7 times 5, or 6 gives you negative 42. 6 times 5, so 5 times 1 is 5. What's negative 42 plus 5? Negative 37i. 9 through 12. Anybody for 9 through 12? I think it's funny the ones you guys pick because these ones aren't really the hard ones.
No, I didn't understand the whole
It looks difficult, so you guys are like freaking out, so you can do it. Now, what do you notice about these two? They're conjugates. So if they're conjugates, simply FOIL them. What's the square root of 14 times the square root of 14? Well, that's the square root of 14 squared. Minus what's I times I is I squared, and that's going to be the square root of 10 squared. This comes out as 14. This comes out as 10. This turns into plus 10. Why does it turn into plus 10? Because it's I squared, right? And 14 plus 10 gives you 24. That was so not a hard problem.
Oh, it looks hard.
Yeah, it looks hard whenever we don't try it.
No, I was just confused on the whole like square root of 13. I didn't realize.
13 would be one that I'd be worried about. 13 is definitely one that has a lot more work to it.
Can you just go to the answer real quick so I know?
No. 1 minus 2i times 1 minus 2i minus 1 plus 2i times 1 plus 2i. Now, you should have learned the trick in multiplying a binomial by itself. It's the first term squared, so 1 times 1 is 1. 2 times the first times the second, so multiply those together and multiply them by 2, so that's going to give you negative 4i, plus the last term squared. Minus a quantity, 1 plus 4i plus 4i squared. So when I distribute this,
Oh, wait, I distribute. Okay.
so what happens? The 1's cancel out. And then I'm left with 8i, negative 8i. And then the 4i squared cancel out, and that's your answer. Hey, did you get that?
Whatever I did, I got 1.
Uh-huh. I'm proud of myself, though.
I said if I would have got it. I did a bunch of work it wasn't needed.
Okay, 14 through 17. Any questions on 14 through 17?
Yeah. What's the conjugate of 16 with no letters in it?
First of all, you have to calculate that. So if I'm on 16 and I have negative 20 and it's asking for the conjugate of that, I first have to put that as a complex number, right? So this is going to be I squared times 4 times 5, which is going to come out as I and 2. So that's 2i square root of 5. So now, what is my conjugate of that? If this is 0 plus 2i square root of 5, the conjugate is going to be 0 minus 2i square root of 5, which is just going to be negative 2i square root of 5. That's your conjugate. So this is the simplified form, and then these are my conjugates. So what's boxed in together? It says write the complex conjugate of the complex number, then multiply the number by its complex conjugate. So what I have to do is multiply these two things together, right? What's that going to give you? 2i times negative 2i is going to be negative 4i squared. And what's the square root of 5 times the square root of 5? The square root of 25, which is 5. So this is going to be negative 20i squared, which is just going to be 20. Why is it 20? Because I squared is negative 1, and negative 1 times negative 20 is positive.
You can multiply the two numbers together even though it's negative 4i squared.
Using your notes. Wait, is I squared 1 or negative 1?
Negative 1.
It's okay.
1 plus the square root of negative 8. What do I do here? I need to simplify this. 1 plus the square root of I squared times 4 times 2. So that's going to be 1 plus I squared. I'm sorry. I, and then this comes out as a 2. 2, so that's going to be 2i squared root of 2. So what's the conjugate? There's that. The conjugate is going to be 1 minus 2i squared root of 2. Now what am I going to do with these two things? And when you multiply conjugates together and they're binomials, what do you have to do?
Foil.
Do I FOIL all of them?
No.
Just the first and the last. So I'm going to have 1 minus 2i times 2i is going to be 4i squared times 2. Why is it times 2? Because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So that's going to be 1 minus 8i squared. And what happens to the 8i squared? That turns into plus 8. So 1 plus 8 is 9.
So what's confusing me is I didn't think you could modify the 2 and 4.
You can't. Did you multiply 4 times x?
Can you do what sort
On your homework.
what's the homework for tonight?
1 through 12 is tonight.
That's 18.
Okay, turn it over. 18 through 21 says write the quotient in standard form. What number? 18. Negative in the middle of 5 over 22i. Can you ever have an imaginary number in the denominator? No. So I need a whole number. The only way I can get whole numbers, Morgan, pay attention, I squared is equal to negative 1, make sure, and I to the 4th is equal to positive 1. Okay? So now, if I have those two values, what am I going to multiply this by right in here? I over I, because I just get I squared, right? So that's negative 5i over 2i squared. And what's I squared? Negative 1, so it's negative 5i over negative 2. What happens to a negative I by negative? Positive. Write the quotient in standard form. That is standard form. That means there's no imaginary number in the denominator. Do we understand 18? 19 and 20, what should you do with those? Actually, I'll do 21 because 21 is a little more involved. What do you have to do with that one? You have to FOIL that. That's going to give you 5i over 4 plus 12i plus 9i squared. What is 9i squared? That's going to be minus 9. That's going to give you 5i over 4 minus 9 is negative 5 plus 12i. Now, am I done with this problem? Nowhere near it. Why? Because I have to write this in standard form, which means I have to multiply this thing by what? The conjugate, which will be and you're going to FOIL. So I'll put parentheses, and that's going to give you negative 25i minus 60i squared all over 25 minus 144i squared. Right? Because you don't have to do inner and outer. That's going to turn it into this 2 plus 60, and that's going to turn it into this 2 plus 144. So that's 60 plus minus 25i all over. What's 25 plus 144? 169. If they want it in standard form, that means they're going to do 60 over 169 minus 25i over 169. Do we see that? Okay, that brings us down to the next section, 22 through 25. What do you want to do? 24? I over 3 minus 2i plus 2i over 3 plus 8i. So when in doubt, if you don't know, what do you do with the two denominators? Combine them. Miriam, so 3 minus 2i times 3 plus 8i on this one and on this one. So what did I multiply 3 minus 2i to get the new denominator? So bring down the numerator and multiply by what you were missing. What did I multiply 3 plus 8i by? Bring down the numerator and then multiply by what you're missing. Marry them. Write them as one fraction. So that's going to be distributing 3i plus 8i squared plus 6i minus 4i squared all over this one denominator of 3 minus 2i times 3 plus 8i. So this is going to give you a minus 8. This is going to give you a plus 4. So that's going to give you minus 4 plus 9i all over. FOIL this. That gives you 9 plus 24i minus 6i minus 16i squared. This turns into a plus 16. So what's 9 plus 16? And what's 24 minus 6? 89. Now, am I done? Of course not. I just made it into one fraction. I had two imaginary number fractions, and now I put them as one. Now what do I need to do? Huh? Is negative 8 plus 4 is negative 4. Still got to multiply this by the conjugate.
Brad, it'll be easier. I made calculators.
I know, I'll show you guys tomorrow how to do that.
I think we should have a class that shows us how to use calculators.